Hey everyone, and welcome to another CTF Writeup video. This is b85 reasons why. One, two, three, fourth. It was the fourth most solved challenge. I'm missing the solves for some reason. I don't know if there's a bug or if all the challenge data got deleted, but the fourth most solved challenge, and it was written by Rory. It says, if you want to catch up on all the campus news, check out my new blog. It even has a reverse image search feature. So right off the back, we know that the bug is probably in here, but spoiling the beans on this challenge, basically we're just going to do a quick little SQL injection, and to do that we have to bypass some b85 filter. With that, let's get started. So this is the blog. It looks like there's 4 posts. I looked through the posts trying to find something interesting. Oops, it froze. Here and here. There's not much. There's some images, some comments. I didn't see anything that was too exciting. There's some about page, nothing really exciting. But they mentioned this image search that was cool, but first I guess we could search for flag. Nothing comes up. So actually the flag format is LACTF, but nothing comes up. And then we can do an image search. So it looks like we can search for stuff. Do I have any images here? Yep. And SQL error encountered. I'm not sure what that means, but that at least tells us that there's something weird with SQL going on. And yeah, let's look at the code. So we were given the zip file. Within it, it has a run.py, so it's just going to start the app, requirements.txt, so we can load everything. There's no specific version, so we're probably not going to be looking for any known CVEs. And then we're given some images. We saw some of these on the blog already. And then the actual app page. I'm not going to go through everything in too much detail. The bug only really exists in one place, but this is the views page. I think limiter is something for brute force protections, and it says 360 per hour, which is pretty interesting. Storage URI, so there's a home page, it's going to load home.html. There's an about page. There's a post page, loads post.html. There's that search page, and it is doing a SQL search. We can see it's searching the post collection. Doesn't really look like a SQL injection here. Eventually we get to the image search. It's checking to make sure there's an image that's being uploaded, checking the size of the image, and here's where things get interesting. So it's going to do some sort of serialized image on the image that we're uploading, and they left a comment, and this comment's just a SQL injection. So I think they're pretty much just telling us to do a SQL injection. They print out the SPIC, I'm not sure what that is, and then right below it you can see right here we're doing a Python format string with that image we're uploading, and we can see this is very clearly a SQL injection. We're able to embed content into a string, and then this is sent to the SQL engine. So we know we have a SQL injection, and that'll return the results. For the SQL injection, it wasn't immediately obvious what we should be trying to do, but if we think more about the query, it says select parent as PID from images, where the image is equal to the image ID that we're about to calculate, and the post is active. Select active from post. This makes me think that maybe there's like a hidden post somewhere that we need to access. So one thing we're not sure about is the serialized image thing. So if we go to utils, it's right here, and it's going to do some weird base 85 encoding. Which I've never heard of before, but it's going to do some base 85 encoding, and then it's going to do some substitutions on that encoding to try and delete all it says delete all the single quotes, but this logic's a little bit strange. We'll talk about that in a second, and then it returns. So it seems like the whole, oops, that's the solve script. It seems like the whole meat of the challenge is we need to construct an image such that the resulting code after it's serialized will be this. So looking more into base 85 encoding, base 85, oops, wrong one, base 85 character set. It is characters 33 through 117, so U. So if we look at man ASCII, it said, would we say 33 to U? So we get all of these characters. Couple interesting things. One is we do have single quotes in the output. That's useful. And one thing that also interesting is we do not have spaces. So we will not be able to get a space out of this. But otherwise, we have plenty of characters to mess with. For SQL injections, we need an equal sign. We're going to do a 1 equals 1, we need the comment character, which we have. So we pretty much have everything except for a space. And they're also going to try filtering out the quotes. So if we can bypass the two of those, it shouldn't be too bad. What's also nice is this check, on a lot of these image upload checks, they'll check to make sure it's actually an image. The only check that's happening is it's checking the file size. So it doesn't even have to look like an image. We don't have to try and be sneaky and embed something in there. We can just put our SQL injection right in there in a file and upload and say it's an image, and then it'll do this SQL injection. To actually solve this, all I did was I grabbed this function, because this is the function we want to bypass, and we know that, and so I put it into this file. This is the solve script. I added some print statements to it, but I copied it out, so it's doing that base85 encode. I print out what that looks like, and then it's doing those 4 regular expression substitutions. So I just print out what the string was before it and what the string looked like after the substitution, just to kind of understand what was happening. And from there, I just started playing with it until I ended up on this string. So let me delete some of this stuff. I'll save that for later. One thing that's super useful when doing problems like this, there's a tool called NodeMon. NodeMon, and what you can do is you can have it exec python 3 solve.py watch solve.py. And what this will do is every time I save this file, you can kind of, I'm clicking Control S or Apple S, it'll automatically run it on the side, so that way you don't have to like type, and then you go over here and you hit run. I'll just start changing the payload here, like 1 = 1. I'll hit S, and I get to see what the output was. So we can see I already have the correct payload here, but it really wasn't too hard to calculate. Like, we can kind of build it out. We know that eventually our goal is something that looks like this, or 1 = 1 comment. But like we said, we can't use spaces, which is a bummer. But so as part of the output, we can't use spaces. And actually, let me back up. So this is that serialized function here. What I'm doing is I'm passing the decoding of what I think the final payload should be. So I'm taking this, decoding it, and so that when it goes to here, it'll call encode on it. So I'm kind of working backwards. But anyways, we know we can't do spaces. But if you played with SQL injections for a while, you might know you can do this. I think you also just Google, because this is a common problem where you're not allowed to have white space in a SQL injection. You can put a comment character in here. This is also just the end of line comments if you're new to SQL injections. This just means ignore everything after the line. So when we look at, if we look at the actual query that'll be executed, when our injection goes through, so we're doing say this or 1 = 1, this is the injection we want. So really it's just going to select parent PID from images where base65 image is equal to empty string or 1 = 1, which is true, so it'll just return everything. And this comment character is just going to say ignore everything afterwards. Cool. So we know we can do these. Again, there's no spaces, so we'll get rid of this. So the only mystery left is this quote character. But if we look at, let's go look at the original function. What's strange is if you go through these substitutions, they say that they're trying to escape all the single quotes, but they actually give us a single quote here. So they're going to replace all of these tildes, the squigglies, with single quote characters. So we can actually get a single quote character as long as we kind of follow this logic. So this is saying regular expressions are a little bit tricky when you use these backslash characters. It's actually a 4-to-1 ratio. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So the way this works is because so 2 of them in Python will go to a single quote, a single slash, and then regular expressions also escapes it again. So all 4 of those goes down to 1 slash. Hopefully that made sense, but you just have to be careful. It looks like it's a whole bunch of them, but it's actually 1, 2, 3, and then the quote character. So it's ignoring pretend this is what it actually is. Obviously this is not valid at Python, but this is actually what it's matching. Anyways, so if we can put that in, it'll put in a little tilde for us, or a little squiggly, and then we're not going to have any direct quotes, and then it's going to take the tilde from this line and just put a quote character in there for us. So nice and simple. So that's what we're going to do. We're just going to take that. This is going to get replaced to a tilde, and then at the very end, that tilde will be replaced with a single quote. Yeah, so this is our final payload. Nice and simple. This will do the replacement. This bypasses the white space, and then we do a 1 equals 1, which will always be true, and a little comment character. And so when I run this, so this is our input, and then this is after the first round of regular expression substitution. This is after the second round, third round, fourth round, and this is our output. So this is what's going to be sent to the SQL query. So this will terminate the quote, or 1 equals 1, comment. As part of the script, every time I run it, it just opens a file called payload, write binary, write, and then I write the base 85 decode of the payload, and that is our payload. So this is what it looks like. So at this point, all we have to do is go to search, image search, choose file, 85 reasons why, where's our payload, and let's search. Cool. And if we search LACTF, there it is. So yeah, there was a test post. And that is the flag. So not too bad of a challenge, just a little SQL injection. Props to the challenge author. Like, they made an entire application for just a SQL injection, or like a little filter bypass. So I'm sure it was a lot of work to make this for a challenge that, only takes a couple minutes to solve. But thanks again, and I'll see you in the next video.